Aloha everyone. This is the operational video for my new 240 volt model of my Aloha Tro Brown's gas generator. I normally sell this for $1,200 and I have the 110 volt model over here, and the operation is identical except that they have the 240 volt model has a 240 volt power supply, and it has a timer switch on the front that it can accommodate 240 volts. Whereas the domestic model, 120 volt model, has a different timer switch and with different timer values. On the domestic model, it's got an off button with 10 minute, 20 minute, 30 minute, and 60 minute buttons. Whereas on the 240 volt model, it has 7 buttons overall, a big off button, followed by 5 minute, 10 minute, 30 minute, 60 minute, 2 hours, and 4 hours. I'm going to go over the operation of the 240 volt model, but I have a 120 volt model next to it with the skin taken off so I can demonstrate some of the safety measures that are in place. And in both models, the same safety features are involved. Now, to turn on the system, you have a master power switch at the bottom here, and when you turn it on, it has an orange LED light. When you turn on the master power switch, the only thing activated is the timer switch, and the button that was last pressed will blink and turn off. The LED on the button will blink and turn off. So when I turn this on, it indicates the 5 minute button was the last button pressed. If I just press the off button, this large button here, that 5 minute button will turn on. So it's just like hitting that 5 minute button, but you have a larger button to press, so it's easier to hit. So if I turn the system off and then I turn it back on, you can see that the 5 minute button blinks. Hit the off button and it turns on. Now I can also do the same thing just by hitting the master power switch and then hitting the 5 minute button. And while it's running, if I hit any other button like the 10 minute button, it will blink and stay on. Now we're running for 10 minutes. And the LED on the 10 minute button will turn off after 10 minutes, as well as the off button LED. And then if I turn it off and turn it back on, the 10 minute button will blink. If I hit the off button, then the 10 minute timer is going. And it will stay on until the timer runs out or you hit the off button. A difference between the 240 volt unit and the 120 volt unit is the difference in timer buttons. So the 240 volt unit doesn't have a 20 minute timer, whereas the 120 volt unit does. Now the 20 minute timer is important because after 20 minutes of bubbling water here, it's fully charged and ready to drink. And it takes about 10 minutes per quart, and this is approximately 2 quarts of water. So it's not that convenient in that if you just want to turn it on for 20 minutes and get fully charged water, it would automatically turn off on the 120 volt system. But on the 240 volt system, in order to get 20 minutes, you'd have to press the 10 minute timer button, wait till it turns off and press it again, or hit the 30 minute timer button and then just wait for 20 minutes and then turn it off. And then your water's fully charged and ready to drink. The timer switch on the 240 volt unit has a couple of features available. One of them is that you can turn off the LEDs so that they don't remain on after you hit one of the timer buttons. And it's probably good for when you want to, if you go to sleep and you want to breathe the gas or bubble the water while you're in the same room and you don't want those LEDs shining. So you can turn on the master switch and then just hold the 5 minute button for 3 seconds, and it will light up, the off button will blink. And now if you hit the 5-minute timer, the LED doesn't stay on, as well as the LED on the off button does stay on. To turn that back on, you just press the 5-minute button again until the LED blinks, release it, and now the LEDs stay on. So if you press one of these other buttons, the LEDs stay on. Another feature of this timer switch is you can control the intensity or the brightness of the LEDs on the front panel. So if I turn it on and I were to press the 5-minute button, the LEDs are this level of brightness as shown. Now if I want to reduce the brightness, I hit the 2-hour button and I hold it for 3 seconds, and then all the LEDs will light up. So if I hold it for 3 seconds again, all the LEDs will light up. Once they're lit up, the longer I hold it, the dimmer the light gets. And then I release it, and right now we're at maximum dim. Now if I want to brighten those LEDs, then I hold the 4-hour switch down for 3 seconds. All the LEDs will light up, and while I keep holding it, they'll brighten up to maximum intensity. Then I release the button, and now we have maximum intensity of the LEDs. This timer switch also has an override, and the override is you hit the off button and hold it, and when you hold it, it will, whatever timer you have going will turn off, and just this off button LED will light up, but the system will be on. And I'll do that here. It blinks and then turns on. So now we're in override mode. It's overridden the timers, and so it will stay on until you manually turn it off by hitting the off button, or you hit the master power switch. Now we'll talk about the PWM controller here, and it's the same PWM controller that's on the 120 volt unit. The operation is the same. So when you press a power button, all power is applied to the system. So the PWM meter comes alive. We'll start generating gas if there are no faults. And you can see that gas is being produced, and we're bubbling water right now. And the backlight for the sight tube comes on so that you can see the meniscus of the water line easier. The PWM controller has 2 controls on it. On the left side is frequency, on the right side is duty cycle. And the frequency is displayed on the top, which is 432 Hertz. That's the default. And it's set at 100% duty cycle. At 100% duty cycle, it's just applying straight DC voltage to the electrolyzer tank. There's no frequency applied. If I were to reduce that duty cycle, like to 99%, now we're applying that frequency to the electrolyzer tank and imprinting that frequency on the bubbled water as well. And if I want to reduce the amount of gas that's bubbling through this, or reduce the amount of gas that I breathe, and the systems, both systems, the 240 volt and the 120 volt system, both produce approximately 1 liter per minute of gas. So if I want to reduce that to 50%, and you might want to do that if you just want to reduce the amount of gas you're breathing, then you'll notice that there's only 50% of gas coming out, so the bubbles have reduced to 50%. And if I reduce it to 0, the duty cycle to 0, then the bubbles essentially stop coming. And whenever the duty cycle is below 100%, you're applying this frequency to the gas and to the water. And if you do some research online about Rife frequencies, That's a list of frequencies for healthful results. And some people believe in those frequencies for healing yourself. And so you could use that. You could use this PWM controller to set the frequency of your choice, and then just set it to 99% or less, and it will imprint that frequency on the water and the gas so you can breathe it. I don't use Rife frequencies. I've used them in the past, but I've decided that I don't care to experiment with them. So I just leave it at 100%. I provide you with a link to an online Google Docs manual, and it's a user manual for the Aloha Tro Easy Water for Life Brown's gas generator. And that includes instructions for both the 120 volt system as well as the 240 volt system. Now let's cover the gas LED. It's a green LED. When I turn on the system and I apply power with one of the timer buttons, everything comes to life. And if everything is okay, then we'll apply power to the electrolyzer tank to create gas, which is bubbling through the water bottle right now. If something were to go wrong, such as if we put too much water in the system and the internal sensor detects it, this high water light will come on. It's a red LED, and this gas, it will stop creating gas. So it'll turn off the electricity to the electrolyzer, and this gas light will go off. And this LED, a red LED, will come on, and you'll hear an alarm, an audible alarm that will stay on along with the LED until you reduce the water level here. So in that case, you would turn off the system and use your drain tube to connect here, take it to the sink and drain some electrolyte out until you get the water level back to the full line. Currently, you don't see the meniscus level at the full line because I've overfilled it a little bit. And so it's just at the top here, but not so full that it triggers the alarm. And I'll show you what that sounds like. So when you turn off the system or when you turn it back on, you'll notice that both these LEDs flash temporarily and you'll hear that alarm sound. And that's normal. Now, I have this system over here, the 120 volt system, connected, but it doesn't have any electrolyte in it. So when I turn it on, the alarm will sound because I have a low water sensor that's on the system, and it will detect that there's no electrolyte. So when I turn it on and I press a power button, I don't have to in this case because it remembers what button was last pressed. But if I turn it off and I try to turn on one of these power buttons, you'll see that the red LED for low level comes on and stays on until I put electrolyte in the system and bring it up past the sensor. Then it will automatically turn off. But also notice the gas LED is not on. So that's what will happen in case where it detects too much water, it's too high, and not enough water or not enough electrolyte is too low. Another way that the green gas LED will turn off is because somehow gas is being blocked from coming out of the system, and inside there's a pressure switch, and when the gas pressure gets up to around 3 psi, it will automatically turn off and won't turn back on until it drops back down to around 2 psi. And then you'll see the green gas LED turn on. Now we'll go over the timer for the 110 volt system. The timer for the 110 volt system has an off switch, 10 minute, 20 minute, 30 minute, and 60 minute timer. So when we turn it on, one of the things about this switch is it remembers what was on when you turn the master power switch off. So when I turn it on, and in this case I don't have any electrolyte in the system, so I'm just putting my finger on the sensor to simulate that there's electrolyte in the tank. And there's a green LED on the 20-minute timer. And that was one that was pressed on last. And to turn it off, just press the off button. And then you can press one of the other buttons and it will turn on. And you notice that the power is being applied to the electrolyzer tank, and the PWM meter turns on, and the backlight turns on to the sight tube. And as this counts down, like from 30 minutes to 20 minutes, the 30-minute LED will go off and the 20-minute LED will come on. And it progresses that way until it turns off. If you want to override the timer and have it just turned on until you hit the off button or the off switch, you just press the 60-minute button and hold it for 3 seconds. And then this orange LED will appear underneath the off button. And now it's on forever until you press the off button to turn it off. Or you throw the master switch. Continuing with the features and the operation of the generator. And this is a model T6633 generator. We'll describe the sight tube. So when you turn the system on and press a timer button for the power to come on, gas being produced, and it'll start to bubble through the bubblers. The backlight to the LED will come on to allow you to see the meniscus level of electrolyte in the tank. Currently, it's up at the top of the tube. Generally, you want to have that down at the full line, because when it's up here, you're in danger of triggering the sensor that detects it's too full, and it won't make gas, it won't apply power to the electrolyzer tank until you empty some of it out through this drain port here. So you want the electrolyte to be at the full level. And then as you use the system, after about 10 hours of use, it drops to the refill level. And from the full line to the refill line is about a cup of water. From the refill line to the full line is about 250 milliliters of water, or about a cup. And you're provided with a 60 milliliter syringe. And it takes about 4 syringefuls to fill from the refill line to the full line, which is about 240 milliliters. The system comes with a 60 millimeter syringe, which you can use to refill the electrolyzer tank, and you do that by taking it out of the scrubber bottle. So you turn the system off, you take the cap off of the scrubber bottle, fill the syringe full, and then input it to the water input port, which is this one-way valve here, and then you just squirt it down through the condenser into the system. And then once you're finished taking it from the scrubber bottle, then you refill the scrubber bottle back to its original level. When the water level goes below the refill line, the metal electrodes inside the tank become exposed to air. And there may be a time when some of the metal particles that corrode off the electrodes may be stuck between electrodes, and when they're exposed to air, then they short out and it may ignite the gas. So you always want to keep it at the refill line or above to the full line to keep those electrodes covered in water so you don't have that situation. So why do you use the scrubber bottle water to refill the electrolyte tank and not just regular distilled water, or distilled water that doesn't have anything in it? Because this scrubber bottle is scrubbing sodium hydroxide in the electrolyte out of the water vapor. And so by the time it makes it to your water bottle, the gas is free of any sodium hydroxide. Well, that means that this water here is capturing sodium hydroxide from the water vapor. And the more you bubble, the more sodium hydroxide's in this scrubber bottle. And this scrubber bottle contains enough water to scrub the gas for about 50 hours. So after 50 hours of use, you want to completely empty this scrubber bottle of water and add brand new distilled water. Water with 0 total dissolved solids. So if you use the system like 1 hour a day, then after 50 days, you would change this water bottle. If you use it 2 hours a day, then after 25 days, you would change this water bottle. Now let's talk about the electrolyte in the tank and this condenser and what it's used for. So the electrolyte in the tank is just distilled water mixed with sodium hydroxide. And once you electrolyze that water, it creates the gas of hydrogen and oxygen, 2/3 hydrogen and 1/3 oxygen, mixed with water vapor. And that comes up through this condenser, out this tube, through the scrubber bottle, and then the gas comes out of the scrubber bottle and into your water bottle. Now, as the gas rises up, it gets cooled and condenses the water vapor in the gas. So that water will drop back into solution with the sodium hydroxide. But some of it still is contained in the water vapor, and so it makes its way into the scrubber bottle. And in the scrubber bottle, we have an aerator at the bottom, which breaks that gas up into tiny bubbles, maximizing the surface area in contact with the water to eliminate the sodium hydroxide in the water vapor. And then by the time it makes the gas out of here, it's free of all sodium hydroxide. And then that gas now is used to bubble the water, and this is the gas output for you to attach your cannula and breathe the gas, or apply the gas to your skin, or to bubble another bottle of water if you want. The condenser has a water input tube with a one-way valve, so it allows water and air to go in, but nothing to come out. But over time I found that this often fails. The one-way valve fails because the sodium hydroxide vapor will get inside the membrane and crystallize and hold the membrane open, and then you'll have gas coming out of this tube. When that happens, you won't see any gas coming out of either of these bottles. And a simple remedy to that is to put your finger over it when you start it up until the gas starts coming out of the bottles, and then releasing it. And usually the membrane will start functioning at that point. Or I provide a cap here that you can use to put it on when you turn on the system, and then take off when you turn the system off. This one-way valve has a low pressure activation, so that you only need to apply a few psi of pressure for that valve to give way and allow water or air to come through. And that helps with a heat vacuum. A heat vacuum can develop inside the tank when you turn the system off. The tank is hot, and as the tank cools down, it'll cool the air that's in the tank, and that will cause a vacuum to form. And that vacuum is relieved by drawing air through this input tube when the cap is not on. So that's why you want to take the cap off when you turn off the system, or just leave the cap off, and if the valve is working, then it'll allow air through the valve in order to relieve that heat vacuum. Now, if you were to leave the cap on all the time, then when you turn the system off and that heat vacuum occurs, it's going to draw water out of the scrubber bottle and into the tank, and could cause a high water level sensor to be activated. It could overfill the tank. in order to alleviate that problem, you want to have the cap off when you turn off the system. In most cases, the vacuum isn't strong enough to pull the water up through these lines when it's in this configuration where the water bottles are down on the floor next to the system. On the top of the condenser here, there's a flash port. And the flash port is a safety pressure relief valve. And that's necessary if the gas ever were to be ignited inside the condenser. The safety pressure relief valve would be activated, allowing that pressure to be released, all that gas to be released, that pressure quickly, so that you don't have any explosion occur. If the water level is too high and this LED comes on and the alarm is sounding, you want to turn the system off and take the system to the sink and drain some of the electrolyte out. And I provide a drain tube that with a stopcock, and right now it's off, so it doesn't allow fluid to go through the tubing. And you would insert the drain tube into this drain outlet here by pressing down on the tab and then inserting it into place. And it will click into place as you push in, then let up on the tab. Once that's inserted and you have this safely in the sink, because you don't want to get any of the electrolyte on you, and whenever you're handling electrolyte, you probably want to use some sort of gloves, rubber gloves or plastic gloves, and you want to use goggles so that in case of an accident where it splashes up, it doesn't hit your eyes. So once it's inserted and it's at the sink, you would then rotate the stopcock to open and allow water to pour out, monitoring it via the sight tube until it gets down to the full line. Then you would close the stopcock. Once it's closed, now you can press the tap and pull it out of the drain. Once it's out of the drain, because the tab is closed, there's still liquid trapped in here. So you want to take it over the sink and then open the stopcock to allow the rest of the liquid to drain out of the tube, then run water through the opening here to allow it to drain through the tube, cleaning it out of any electrolyte, and then just rinse off the tube. And then when you put it away, you want to close the stopcock, because you don't want to ever attach this while the stopcock is open, because then it'll just start draining immediately and then you'll have a problem. The water in the water bottle is distilled water, and it becomes fully charged and infused with hydrogen and oxygen after 20 minutes. And this contains 2 quarts, so that's about 10 minutes per quart. If you were to take a ORP meter, an oxidative reductive potential meter, and you measure the charge of the distilled water before you run it for 20 minutes, it will register somewhere around 402 to 600 millivolts positive. After you've bubbled it for 20 minutes, it will run about minus 450 to minus 600 millivolts negative. So you've applied a negative charge to the water, and it's infused with hydrogen and oxygen. And that hydrogen and oxygen, as well as the charge, will last for about 12 hours. So after about 6 hours, half of it is gone, and after about 12 hours, it's all gone, unless you do something to make it last longer, like putting it into an aluminum container and capping the container. It's very much like a carbonated soda, that when you take off the cap, that carbonation slowly exits until the soda becomes flat. And that's similar to what's going on here. So you want to drink the water for maximum therapeutic value as soon as you bubble it, or soon after you bubble it. The longer you wait, the less therapeutic value there will be in the water. On the side of this system, I have a ground lug, a copper ground lug, and it's connected through the chassis to the ground line on the power connector. And whenever you plug in the system, you want to plug it into a grounded connector or a grounded power socket. One of the things about the gas is that it is flammable where it's coming out. There have been accidents where through a static discharge it's ignited gas that's been in a glove or a leg glove. So you want to discharge any static electricity from your body before you use the gas. So I supply this ground lug so that you can easily touch it to ground yourself, or you can buy a ground strap, either a wrist strap or a leg strap or a grounding mat that you can attach it to this ground lug and have that on while you're using the system, or standing on a grounded mat while you're using the system, to eliminate that possibility of a static discharge. On the back of all systems, we have an hour meter that records the hours and tenths of hours of the electrolyzer being powered. So it only records whenever that electrolyzer is generating gas. And we want to know how many hours of use because we want to maintain the system. We want to clean it after every 150 to 200 hours of use. And that approximates, if you're using the system like 2 hours a day, about 6 months, and then a year if you're using it 1 hour a day, approximately. And it doesn't have to be strictly within 150 to 200 hours. There's some variability there, whatever makes you feel comfortable. You want to clean the system because as the electrodes wear, they rust, and those rust particles get into the tubing and they eventually will clog it if too much occurs. So you want to clean the system regularly to keep it at maximum efficiency. There's also a syringe holder on the back here that will conveniently hold your syringe for you to use in refilling the system. Then there's the fan and fan grill, and then the power socket, a 3-pronged power socket.